Hi, in this video we are going to see how to update Ardupilot source code to add new modification to the OBAL board. Let's first see what changes have we made. This is the original OBAL board. As we can see, we have IMU 9250 and it is connected via SPI. And we have here a Baro PMB 180 and it is connected using I2C. As you can see here, this is the chip select line that is used to control the IMU, and the board already contains another pins for the SPI device with the SPI chip select one connected to it. The modification of the new board is here. I replaced the IMU 9250 with the GY91. The GY91 contains IMU 9250 and contains the barometer BMP 280. So this I2C baro is no longer needed. That's why I modified the layout slightly and removed the BMP, the barometer, because I no longer need it, and I can free out some space on the board in order to add external sensor or just to try to reduce the number of components on the board. The philosophy behind OBAL is to use it as Lego and be able to test different sensors on it. That's why I'm trying to make some variations. In my opinion, that the I2C now is less crowded by others, because already we use the I2C bus for this chip and this chip, and we can add external chips such as an external compass, for example, on the I2C bus. So I'm trying to reduce the number of devices connected to I2C bus, especially that by adding the barometer to the SPI, I'm not adding too much load to it, and it works well with the and it works well with the IMU 9250 in this chip that contains them all. So why not use the SPI and reduce the number of devices connected to the I2C? This is the philosophy behind this modification. Now let's go to the code and see the changes that we need to make. We only changed two files, the Linux file and the SPI file. As we can see here, the Linux file and SPI file. Linux.h is a very important file. It exists here in the library OBAL board, and its function is to define the sensors that we use on different boards. If we go through this file, we will find many boards here, and one of them is the OBAL. This is the original definition of OBAL. As we can see, we define the OBAL MPU 9250 SPI. We define in it the log file path, the trim path, the parameter file that the Ardupilot will create. It will be stored in this folder. Now let's go to the sensors. Here the MPU 9250 is defined. Here we define the accelerometer and the gyro. Then the magnetometer or the compass is defined here and link it to the MPU 9250. And we define the baro as external baro on the a baro on the I2C bus on address 0x77. It's a hexadecimal. And we define it as BMP 085, and 085 and 180 are compatible, at least from the viewpoint of Ardupilot. You can access them the same, so that's why you can define this driver and safely access both BMP 085 and BMP 180. Okay, the modification here, I splitted the definition of folders here. I added here an extension because I want to run the same Raspberry Pi on different shields. So when I put the shield that contains the GY1, I run the Ardupilot, that is Ardocopter or Arduplane applications that compiled using this definition, and then it will access this folder. When I run the original OBAL board, I will run it with the binary that compiled with this option, and it will access this folder. Here it is, the definition of the original OBAL board. Now let's focus on the new definition of the new or the modified version of OBAL. The modified version of OBAL defines the same SPI, the same IMU, but when it comes to borrow, here we don't define I2C, we define an SPI borrow and give it the model of the SPI, which is BMP 280. We still allow external campus. Other than that, everything is the same. You can activate the original definition or select the modified definition just by comment and uncomment this. So if you uncomment this and comment this, it will and compile the code, it will generate the original binary with the SPI with the SPI that used 9250. And if you compile it with this option, which is the case now, it will compile it with the new modified design that access GY91. Now let's go to the SPI device file, because now we finished the definition of the board. We need to put some specification for the SPI bus. The original line is here. This is the original line that defines MPU 9250 and attach it to chip select 0, which is this line, chip select 0. Now we define the same line, but we add here another line, which is BMP 280, and attach it to chip select 1 here. This is the minimum and maximum speed of the SPI bus that need to be used for accessing these chips. If you try to reduce this to lower values, you might find some deviations in reading the gyro. So I found that these are the suitable values that Ardupilot can access this sensor safely. Thank you for watching this video, and please remember to watch the other video that show you the physical board itself. Thank you very much.